True bearings. There's a few things that you have to remember when you're working with true bearings. The first is that you write using 3 digits. The reason for that is to avoid any ambiguity in the bearing that you are given. So it's to ensure that a bearing of 38 degrees is actually 38 degrees and not a typo where someone didn't type in the 1 when it was needed. So that's why bearings always have 3 digits. The second thing is that we measure our bearings clockwise from north. Always. And north is 0 degrees. So when you're working with this, that gives us an easy reference point and something you should include in all of your diagrams involving questions with bearings. What you then need to do is imagine that this is a bird's eye view and there's you. You're that orange dot. That orange dot is your head. What you're doing is looking north, and then to get the value of the bearing, you then turn some angle and walk in that direction. Now you're on that orange dot, you're looking north, you then turn around and the angle that you turn, that's the bearing. Okay, so let's look at this first one, a bearing of 36 degrees. We start by facing due north. Due north means directly north. And we're going to turn 36 degrees. Now, hopefully everyone recalls that that would be 90 degrees east, south would be 180 degrees, west would be 270 degrees. So 36 degrees is going to be somewhere in that region, and you don't have to do these diagrams to scale. So there we go, 36 degrees. That is a bearing of 36 degrees from the point O. Now, what that might mean is that someone is walking from O to B. Don't know why I picked B. That might mean that someone is walking from O to A on a bearing of 36 degrees. So if I wanted to get from O to A, I would stand at O, face north, turn 36 degrees, and then off I go in that direction. Okay? So that's A. B is a bearing of 150 degrees. So again, we're going to start at the origin. We're going to face north, and this time we're going to measure out an angle of 150 degrees. 150 degrees would be in that quadrant. So we turn 150 degrees and off we go, walking in the direction of B. This angle in here then, that's going to be 180 minus 150, which is 30 degrees. Okay, and often it's this angle here that we end up working with in our triangle. C, 206 degrees. 206 degree bearing is going to be in that quadrant there. So, we stand there, we face north, and we turn in an angle of 206 degrees, and off we go, walking towards, say, point C. So if this angle is 206, this angle in here is 270 minus 206, which is 64 degrees. And that might be the angle that forms the triangle that you want to work with. At this point, I'd like to stop and talk about the third thing that we can say with bearings, and that's that the back bearing has a difference of 180 degrees from the forward bearing. Okay, now what does that mean? Well, that means to get from O to C, right, the bearing from O to C is 206 degrees. The bearing from C to O will either be, well, it will have a difference of 180. So you're either going to subtract or add 180. If you add 180, then you get a bearing of 386 degrees, which of course doesn't make sense because 360 degrees just gets us back to 0. So if we subtract 180, what we get is a bearing of 26 degrees. That is the back bearing. Okay, the bearing going back from C to O. If we think about a set of arrows there, that direction is north. Okay, if that green angle is 64, so is that one. What must these two angles add up to? 90 degrees. 90 take 64 is 26 degrees. The final one is 353 degrees. That is going to be in this quadrant here. So we face north and we turn all the way through 353 degrees. That's almost 360. And walk towards D. This angle in here is going to be 360 minus 353. 7 degrees. And it's probably that angle that will form your triangle. That angle there, that would be 353 minus 270. 83 degrees. Okay, so it's about looking at the diagrams and thinking, right, is it the one inside there, or is it the angle outside? The other thing we want to be able to do is write certain bearings. So if we think about walking from P to Q, and what is the bearing of that? So we would have to face north and turn that angle. That angle is composed of 180 degrees plus 45. So the bearing from P to Q would be 180 plus 45 degrees, which is 225 degrees. The back bearing would be 45, a difference of 180. Let's have a quick look. What is the bearing going back? Well, if this angle's 45, so is this one. So the back bearing, 45. In the second example there, we face north, and we have to turn all that way. Well, that's 180, and that's 157. Bearing from P to Q would be to go 180 plus 157, which is 337 degrees. Starting from point A, so one of the key success criteria here is that you can draw the diagrams correctly. We're starting from A, we travel 7 kilometers east, and sometimes it would say due east there, which means directly east, to B, then 3 kilometers south to C. So obviously we can see there's a path there, okay, and it's made a right-angled triangle. Let's draw in a north arrow so we have some reference. And the key thing here is that it says of C from A. That from A tells you where to start. You are starting at A. And we are needing to find this bearing. Okay, that bearing is made up of 90 degrees plus this angle in here, which I'm going to call theta. So, looking at that triangle, we've got tan theta equals opposite over adjacent. Theta is the inverse tan or arctan of 3/7, and that works out to be approximately 23.2 degrees. Therefore, our bearing in this question is made up of 90 degrees, the right angle in green on the diagram, plus theta, which is 23.2 degrees, to give us a bearing of approximately 113.2 degrees, or 113 to 3 significant figures. So we've got an aeroplane departing from A. You've got to make sure diagrams for this are drawn. Try for the center of the page. Otherwise, you might not have enough space. So there's A, there's north, and it flies on a 143 degree course. Sorry, let's draw up all relevant points there, northeast, southwest, for 368 kilometers to B. So, to get from A to B, we have to turn 143 degrees and go 368 kilometers. So 143 degrees would be 90 there, plus 33 degrees. And that gets us to B. It then changes direction, so you would want to draw another set of compass points on that point B, and its direction is now 233 degrees, which means about there, and it's further, so try and make your line longer. This doesn't have to be to scale, but try to approximate it so you can get an idea of where the final line back to A actually ends up. If you had drawn this too short, it's misleading and you might think it's north. So try and get it as close as possible to scale. Oh, I'll get it right in a minute, 53. So, if that's 53 and that's 53, by the Z rule, we know what that's going to be, 53. Okay, and 90 take 53 is 37. That means that's a right angle there. And we know this length is 472 kilometers. And so now we could work out the distance from C to A. The best way of doing that would be to use Pythagoras. The bearing of C from A, this one is asking for that bearing of C from A. And so we know that this bit's 53, this bit's a right angle. So now that we've got this diagram set up, pause, have a go at solving this question. Okay, for part A, using Pythagoras, that's the hypotenuse, so the distance would be the square root of 368 squared plus 472 squared, which is approximately 598.5 kilometers. The bearing is there's multiple ways we can do it. Okay, let's look at the idea that it's 143 degrees to there. Okay, ultimately what we have to do is find theta. So let's start with that. And I'm going to use tan. Tan of theta is opposite, 472, over adjacent, 368, which is equal to the arctan of that fraction, which is approximately 52.1 degrees. So, if this bit is 52.1 and this bit is 143, that means the bearing of C from A is equal to 143 plus 52.1. 195 degrees to 3 significant figures.